Tuttle here for Ferguson Roof Systems. For 43 years, Ferguson Roof Systems has been protecting Oklahoma's homes and businesses with quality roofing services. Their goal was to be the most honest and dependable roofing company in the state, all while providing free services such as lifetime labor warranty and annual inspections. Well, mission accomplished with thousands of client testimonials, an A+ Better Business Bureau rating, and a 5-star rating on Google. Look, the weather gives you enough to worry about, so why worry about who to trust with your roof? Call Ferguson Roof Systems today or find out more at fergusonroofsystems.com.
Let's try that. That. All right, that's what I want to see. All right, we're about to start. I had to see something real quick. A little visual for you. All right. Guys checking in, I see you all over the place here. So, all right, well, my head hurts. I need to take a minute to compose myself. This is the forecast that separates the men from the boys. I just don't know if there's going to be any men left. Oh, what a nightmare. All right, so thanks for joining me. Thanks for tuning in here in our lunchtime live. Like I said, my head hurts. These are the worst type of forecasts to make because you're on the line. And I'm on the line where it's rain or snow. And you guys, most of the time, as you guys know, when we're in this position, it goes to rain. So if you're going to go with history, and common sense and, the usual stuff, you don't get too excited. You get disappointed and you go, it's just a cold rain, right? I want to show you why that is, which is what I was working on just a minute ago to give you a good visual of the nightmare that we're in. So let me, I'll get a couple more, another minute or two, let more people pile in here real quick, and then I'll show you what that looks like. Meanwhile, out there currently, for our lunchtime live on Friday, by the way, happy Friday. Hope you're going to enjoy your rest of your weekend coming up. Maybe you get to celebrate a little bit early. Maybe you're kickstarting right now with a cocktail in your hand. Don't tell your boss. 59.4 degrees, cloudy skies out there, so that's not a pretty Friday at all. But at least it's kind of on the mild side. So again, we're about 60 degrees. We'll be in the 60s again today. 70s probably down south in the southern Oklahoma. But all right, so let's take a look. A real quick graphical explanation as to why my head hurts. You ready? All right, so this is a really good way for you to understand what's happening in the atmosphere, and then I can show you the data underneath this nonsense. So yes, in this particular case, you have clouds that generate snowfall, and these are temperatures in the atmosphere from surface all the way up. So again, ground level up to the sky. This right here is the freezing line. This is marked 0 for Celsius, okay? But you can also picture 32 for Fahrenheit for us American lovers of the imperial system. But what you'll notice is, as long as temperatures are left of this line, it's all snow. Now watch what happens. This is what's going to happen on Sunday. See how far this snow travels down? I mean, it's snowing to beat the band. And look at the tops of the city skyline. See that right there? Look what happens to that snow as it starts to reach the top of the city skyline, about where we live and breathe. You see what it transfers over into? Yeah, that's wet raindrops. So the snow will be crazy. So when you hear, it's been snowing to beat the band at 1,000 feet, or it's snowing like crazy at 500 feet, and you're like, well, I don't freaking care. I don't live at 500 feet. Where's my snow? This is what happens to it, all right? And this is because a profile in the atmosphere is below freezing all the way up, except for when you're right here at the surface. Now, this is where the models are having fun, because some of the models say we're going to be right around 2.1, like I'll just say 2 degrees Celsius, all right, here at the surface. Well, some models are going, nah, we'll be closer to 1 degree Celsius. Now, that's not freezing, so as you know, that's 32 plus a little bit, right? So it's about 34 degrees. So if we drag this number down to 1 degree Celsius here at the surface, right here, and where we live and breathe, instead of 2 degrees. That's 1 degree difference. Now, of course, it's in Celsius. So if those of you folks don't know, it's like 2.54 on the Fahrenheit scale. So technically it's 2 degrees, we're talking about Fahrenheit, but 1 degree is talking about Celsius. So look what happens. You see any more raindrops? No, it is pure snow. Heavy snow, crazy snow, feet of snow. 1 freaking degree. And that is why this is a nightmare, because the model resolution that we use, no matter how many I show you, is not good enough to tell you which side of the coin it's going to be on. So flip the coin and there's your solution. And I can show you all these models, all these maps, and tell you everything. And at the end of the day, this is what it boils down to. It is a nightmare. And I've been confident in the past, when I was my young whippersnapper self, and go, it's going to change over, it's going to change over. And I would see times where it never changed over. And I just like, why didn't it change over? Well, there's some things that happen that models just can't see. All right, so that's the big picture. All right, that's where we're at. If I want to show you what that looks like going up in atmosphere with the active readout, I'll just pick the NAM model here. We'll go with it first. And I'm going to point, this is Oklahoma City, for example. So this is Sunday afternoon. So what you're going to watch is, here's that freezing line right here. Now this time it's on diagonal versus up and down, but it's diagonal, same idea. But down here at the surface, right here, that's where we live and breathe. That's 3.6 degrees. That's obviously too warm. So we get raindrop as the solution. Okay, so that's Sunday afternoon. Here's 3 o'clock. Look what happens. There's still 3 degrees, but the model's trying to say, no, we might start getting some snow reaching down the surface because we're below freezing all other levels of the atmosphere except for the first few hundred feet off the ground. All right, let's go to the next hour. All right, 4 p.m., 5 p.m., all right, and our surface temperature is now cooled. Ignore this number here. I don't know why that's there, but the number down here we won't look at is 0.6. So in other words, as long as we can get that temperature below 1 degree Celsius to the left of this side, then we get all snow. And so that's why the NAM is going all snow here for Oklahoma City, right at the line. I mean, it never gets below freezing. I mean, it's still right about above, like half a degree. But the point is, as long as this particular profile pans out, we are dumped on. If it's added another half to 1 degree to that, it's just a cold rain. So when you look at the output of this particular model here in Oklahoma City, just to show you, if you tally up the window of snow here, which would be from mid-afternoon, so after 2 o'clock or so, up to about midnight, it's 8 inches of snow here in Oklahoma City. All right, so you have plenty of lift in the atmosphere. There's little red omegas, plenty of green, plenty of moisture, correlates to the snow growth layer, and even down below it. And like we said, it's just those surface temperatures. This is what's causing it right here. So that's it. I could end the broadcast. You now have the forecast: rain or snow. That's the way it's gonna go. Ugh. All right, so now let's go. Let's talk about what else we got here for you. Now that you know the good news / bad news. The Weather Service is scared too, so they backed off the sunny snow potential quite a bit, kind of keeping it high out here in western Oklahoma and southwest of the metro. Then lighter amounts. Again, the focus is I-40 and 44 and 35 down south. The heavier snow amounts, they've also backed off on that and kind of kept it down here across far western Oklahoma. Look at the new model data here in a second. The Tulsa only has a dusting to about 1 inch of snow across the northern half of the state. Ironically, they may have to shift all this down to the central part from Tulsa southward to McAllister, believe it or not, in the latest data. I'll show you that in a second. The current ground temperatures are way too warm. They're in the upper 40s, near 50. And that's why the snow will melt so fast. All right, so here's a look at the jet stream pattern for Sunday. Stop right here in the morning hours. So this is our system right here. Moving into the Red River Valley for midday Sunday, and then by Sunday evening, parking itself right around Ardmore. And then it moves to the northeast from there, around Fort Smith at midnight, northwest Arkansas, and then Missouri by the time you hit the daybreak for Monday. So that's our storm system. Now I'm going to show you what it looks like if we compare different models for the same position, for the same timing. So let's go to Sunday evening. So let's go to 6 o'clock, 7 o'clock. All right, so let's just find out where the center of the upper level low is. And we've done this before, and this is so critical as to who gets snow or even a chance of snow and who doesn't. All right, so there's the American model, like so. Icon model's over here. The NAM model is really close to Icon, right about like so. The Canadian is over here with the GFS. The UK Met back out here. GFS, let's see. Let's go. European splits the difference right about here. Okay, so they're still not in very good agreement as far as the placement upper level low. And you're like, well, why is that such a big difference? You have no idea. Because if a low's down here versus down here, it takes all the snow potential with it to the south. But of course, it's going to run out of cold air to work with too, so it's a kind of a catch-22. The more northern track, the better the snow in this area, and a little bit slightly colder air to work with. So again, it all depends on the track, and the model still can't decide the exact track. So this is why I was hoping today we would have clarity for you at lunchtime. I really did. We're in that just now hitting that 48-hour window. I may have to wait till tonight and tomorrow is what it is, but we'll see. We'll get the data here. I haven't had a whole lot of time to process this because there's just too much. But let's just take a look here at Sunday. What I want to focus on is the track of the NAM model. Let's just assume the NAM is on it, right? It's got it, hasn't wavered. It's done deal. If you look through the evening hours, you can see this large area of lift in the atmosphere. Now, this is the I-44 corridor that runs like so. So the difference in today's data versus yesterday, the same look, same track, but a slight jog to the south. So in other words, the heavier amounts of snow, instead of being along in north of 44, they're along in south of 44. So that's a slight difference. So see, just a little jog can just change the position of the heavier precipitation. Okay, now this is the key factor as well. This is what we call, and this is where things get frustrating. All right, so this is what we call the column max temperature, surface to 500 millibars. In other words, where is the maximum temperature plotted in that whole vertical profile of the atmosphere? And what we care about, obviously, if it was all freezing, 32 degrees or less, we're in good shape. Or in this case, 0 degrees. We're not going to have that, obviously, for most of the region. We're going to have plus 1, 2, 3, which is why I started this show in Celsius, because this is what we have to use on these maps to indicate that for you. So, for example, let's go with the NAM model. We'll use this one first, just to show you how finicky this is going to be when it comes to who gets rain and who gets snow. And we're going to assume this model is 100% on it, just so I can show you the differences in the deviation. Okay, so you see where this dark green is here on the map? You can read that active readout. That says 0 to 1 degree Celsius. All right, there's your snow. So I'm going to outline this for you. This little patch here is snow. This little patch over here is snow. Okay? What is not snow? Everywhere else. But it's raining, but this is the only spot getting snow. You see what I'm saying? All right, so now if you go outside of that little darker green to the little secondary green, it kind of goes to the 1 to 2 degree. So I'm going to clear this back and we're going to expand it. So I'll include the potential where we'll say the most, not quite that good, but it's close. So we'll go something like this. We'll get this little secondary green contour in here, all right? And we'll do this thing like that. All right, so there's your snow for 6 p.m., 7 p.m. on Sunday. So you can see if you go to the north side of Oklahoma City, toward Guthrie and Stillwater, it's plus 3, plus 4, plus 5 real fast. So in other words, just a cold rain. And of course, you go south around Ardmore, down southward, it's plus 3, 4, 5, 6, 7, all the way up to Dallas is plus 10 degrees Celsius at the surface. So again, this is it. This is your tiny little pocket of snow. And that's just that one instance in time. If I fast forward 3 hours after that, you're going to see it kind of, let me do this. Let's put this on here so I can quit. Don't have to keep changing it. Okay, so now look how it's broken down. So your area's kind of shifted like this. And this is cold air mixing down to the surface from the column of the precipitation, because it's not like from a front coming around. It's just from the back end of that upper level low, and just forcing all that cooler air to come down with the rainfall. And so there now is your area of snow at, say, like 9, 10 o'clock in the evening. Again, outside of this, plus 3, plus 4, plus 5, over here, plus 6. That's it. So you are tracking a very transient, tiny area of column cool temperatures to where it's cold enough for snow to happen. Now, when that happens, it can be crazy, it can be heavy, it can be nuts, it can pile up in inches really fast, and it can melt almost just as fast. So the measurement of this, regardless of what falls, is going to be difficult. But if you're out there to enjoy it while you can, kids, wise, etc., live it up, because it won't be around long. But anyway, I wanted to show you this is what we're talking about when you're talking about frustration level in that particular case of the forecast. All right, now if we look at the what they call the dry slot, where's the precipitation going to come to an end? On Sunday, right here, it does move across southern and southeastern Oklahoma during the afternoon hours. But if you notice, our pivot point right here in Oklahoma City, we never get into the dry slot. We kind of stay into the moist axis, and this is all be snow from Sunday evening to midnight, especially this little heavy batch darker colors, which indicates some very heavy humidity values, up around 100%, right? So you get the heavy precipitation. So that's not so much of a factor as what we're talking about is the temperatures. And when you want to look at the actual temperatures, let's just, by the way, today, like I said, here, don't mean to dismiss that because my focus is obviously on Sunday. But today, 60s out there, maybe some 70s down here in southern Oklahoma. All right, so on Saturday, because of cold front that comes in tonight for tomorrow, we're a little cooler. A lot of 40s and upper 40s and mid 50s, so pretty decent Saturday. Okay, so let's go back to Sunday. And this is kind of how that can look. So Sunday at noontime, remember we're talking about what's happening just a little bit off the surface down to where we live and breathe, just a few hundred feet down. So let's go to 3 o'clock. So we're too warm for snow here in Oklahoma City, for example. Now we did look at the NAM that says it should start to transition over about this time. You do see 36 degrees on the southwest part of town. So that's kind of the cutoff. 36 is the cutoff. That's pushing it. Colder than that, yes, it can happen. So 37 is too warm. But let's go to the 6 p.m. time frame. All right, so now this is where you see the current readout. So there's 35 Oklahoma City, 33 on the southwest side of town, 33, 44, Norman, down here to Lawton, down to around 33, 34. So then this contour area is where you get your snow at this particular point in time. And I cut it off. It goes all the way out here. But so everything else, this is all rain. So it's this little pocket of transient temperatures to go through. So here's 9 o'clock. And there's that little area kind of going like this, moving like that. And it kind of just moves northeast because remember, it's moving along with the track of the upper level low. So it's coming around the back side of it. And so this is where you get your mixture of rain and snow. Fingers crossed, and sometimes they go back and forth. It can be rain for a while, then snow for a while. Sometimes, in the past, once it tends to transition over, it stays over. Not always the case, but in a lot of cases. But anyway, so that's kind of how the intricacies look. When you look at the output of everything, we're going to have a little bit of rain for Saturday in the afternoon hours across southern, southeastern Oklahoma. And there's that snow across Colorado, New Mexico. More rain for Dallas Saturday evening and into southeast Oklahoma. As we head into the overnight period on into Sunday morning, there's that heavier rainfall moving into central southern Oklahoma, Dallas, all the way back out west, which it changes over to snow from Elk City into the Panhandle. So a lot of heavy snow for the Texas Panhandle. They've got no problems transitioning over. But you can see at noontime where that line in the sand is. And if you go into the afternoon hours, you can start to see it trying to get peppered in here from Oklahoma City down south and west. And then it kind of changes over here to mostly snow from south and west of the metro on into southwest Oklahoma. Still rain to the east. And then into the evening, we get that colder air expansion. The sun's over with. We've lost our solar insulation. Now we got nighttime, which will allow temperatures to cool just a little bit. And bada bing, bada boom, get a little bit better shot of seeing some transition to snow and for it to not melt back over to rain into the midnight hours. And that moves on off to the north and east into Missouri by daybreak on Monday, to flurries and moving out of the way here. So here's a close-up view of that, because I know it was a big picture, but I'm going to give you the big picture before I give you the small picture. Okay, so there's a little sprinkle activity for Saturday, moving across the southern half of the state. No big deal. And then here is a look now into Sunday morning. Thanks to that rainfall moves in. So if you do have any plans on Super Bowl Sunday, it's going to be a wet day in general across the southern half of the state to start with. And there's that snow there to the Panhandle region, Amarillo to Childress, a little bit of Elk City by lunchtime. And then as we head into the afternoon hours, 2 and 3 o'clock, some heavy rainfall down there in southern Oklahoma. Now, this is the NAM's little brother. And I say little brother. It's the higher resolution version of the NAM, and I think it's an error. It's got some problems. I noticed it's got too much dry air. It's bringing in at the lower levels, which I'm really not sure how it came to that conclusion, so I'm throwing it out. So in other words, it doesn't have the snow moving that far north, kind of has it in this vicinity. In reality, it should be like the NAM's brother, so I'm going to go back to that. When I was looking earlier, I saw that, and I said, I better put that back over to the big brother versus the small brother so we can get the point across. Okay, so here's 3 o'clock. like I said, there's that transition of snow from southwest side of Oklahoma City back to Elk City and Lawton. And then by 6 o'clock, again, the game's already started. You're probably already where you're supposed to be. If you were in southwest Oklahoma, you'd had to drive through some snow. Elsewhere, you're driving through some rain. And then in the evening hours, there's that snow from 6 to 9 o'clock across central Oklahoma, points to the south. Look at the model still struggling to try to transition it over from rain to snow here in Enid and Ponca City, for example, and Tulsa. North side rain, south side snow. As we head into the midnight hour, now it has finally cooled down most of the column, and there's your snow as a result. And for fun, I'll do a click point forecast here just so you can see the difference. Okay, so here in Oklahoma City, it has 35 over 34, and it still has snow as the recipe. All right, so that's right on the end. Now, if you go up here in this green area, I'll just pick north of Tulsa, it says 37 over 35. All right, technically, that's too warm. It does say still snow for the precip type of the sounding because it is generating snow. It's just melting at the very bottom. So that is why the colors are flipping back and forth. It's probably got a hard-coded parameter in here. If it's 30, 6 plus up above 36, it probably paints it green. And if it's below 36, it paints it blue. So hence the reason there. But there'll be a little bit of fluctuation within this large area. So yes, it's still going to snow. Yes, it's a mixture of rain and snow. Yes, some accumulating snow. Yes, a lot of melting snow. So that hasn't changed. It's just trying to nail down the exact track is obviously difficult given what I showed you how we started this thing. Okay, so let's take a look at snowfall totals. Keep in mind, regardless of what happens, it's still going to melt a lot of it, but you'll get enough of it short term. Just to show you, and then I'm going to show you, and actually, let me do this first. Because I need you to understand why the model's going to go so much snow first. So let's just forget we have, cold enough temperatures to even produce snow. The precipitation in the atmosphere that we have to work with is crazy for this time of year. Again, El Nino brings us a lot of moisture for the winter time, and we can tap into that. We're good to go. So let's just look at the different models just to show you how much rain is expected across our region through Monday morning. So this is all day Sunday to Monday morning. So this is widespread 1 inch plus to 2 inches down here in southwest Oklahoma across the I-40 corridor and southward. All right, so that's the European. The global version of the Canadian, same kind of look, a little dry here west, otherwise still southern half, a lot of good rain. The American model shifts that rain to the north a little bit more, up to around Ponca City and Enid, and then back out here to Elk City, hard line in the sand. Again, not much up here, but otherwise widespread 1 to even 2 inches of rain. Here's some for 3 inches of rain. Now, earlier, remember when we saw some of those outputs throughout the week where we had 30 inches of snow? That's why. If you could get this to be all snow with a factor of 10 to 1 ratio, that's 30 inches of snow. 3 inches of rain is 30 inches of snow. And this is why the models went so excited about snowfall totals. Icon model, again, widespread 1 to 2 inches in this little purple area. It also likes that little dip down here to the southwest. The NAM says forget the dip. Let's go back up here to 3 to 4 inches, southwest Oklahoma, 1 to 2 elsewhere. Let's see, the Canadian version, high resolution, 3 to 4 inches of rain south of Oklahoma City and down here to southwest Oklahoma. This is going to be key here in a minute. I want you to focus on this little spot that says 3 because the Canadian thinks it's going to be mostly snow for Sunday afternoon and evening. See what it does with that. The UK Met also has I-40 corridor south, 1 to 2 inches. Blended models, which is the most conservative, takes them all, averages it out, lowers it down a little bit. Widespread 1 to 2 inches of snow of a rain along I-40 southward with the hard line of the sand around I-44 up here to Tulsa. Okay, so bottom line is a lot of precipitation is going to fall. Now, if temperatures were cold enough, excuse me, all choked up over this, all cold enough, that's where you get a lot of the heavier snowfall amounts. So the GFS, the American model, is 1 foot of snow out here west-southwest in Oklahoma. Now, when you look at the QPF of the rainfall, you can say, how that could happen. That's not bad. That's saying 2/3 of it is in the form of rainfall and 1/3 of it's in the form of snow. That's not a bad solution. All right, so let's see, which one am I on? Yeah, I'm on the Kutra. The European is having a tough time now all of a sudden and deciding whether it's going to be rain or snow, so it keeps it mostly rain. Therefore, its snow amounts are far less, 3 inches, 1 to 2, dusting, 1 to 2, this little stretch here just south of 44. All right, and then 35 and out to the west. Let's go to the Icon model. Icon's like the European as far as the track, but it's much heavier on the snow output. 4, 5, 6 inches up here and 10. By the time you get to northwestern Arkansas, a little gap down here in southwest. And then let's go to the NAM model. NAM model of Southwest Oklahoma, 21 inches. Otherwise, 8, 6, 5, 4, 3, 2, 5, 4, 6 up here. Again, I-44 corridor points south. And then the Canadian high resolution, the short term. Remember how I told you to watch that little spot south of, like just around the Norman area? 11 inches of snow because it went for that big bullseye precipitation. It's got weird bullseyes out here at the west. 9 inches down here, 8 inches down here. So you now understand the difficulties in forecasting snowfall in events and how it can be a total nightmare. And you guys get really upset. I understand it because you want it to be perfect. So do I. Trust me, I want to be more perfect than you do. It kills me and I can't. I mean, it drives me crazy. All right, so there's the European close-up view. Again, Oklahoma City south and east up to Tulsa. There's the American view, kind of similar track, right along I-44, split the difference out here on I-40. Believe it or not, I really kind of like this general look. I've talked about this now for the last couple of days, so I haven't really wavered. I still like this general look for Oklahoma as far as the track of the snow, with the heavier snow kind of in this southwestern quadrant. And the secondary spot, because of nighttime without insulation, out here in the northeastern area of the state too. So those are the areas which I do like. So far, that's not bad. Now the icon's a little south of that. And like I said, the NAM is kind of back into that sweet spot, but it really tries to narrow down who's getting it, who's not getting it, all that kind of stuff. All right, let me close this down. Get that off there. Okay. So at this point in time on Friday, again, that's great, Aaron. How much is it going to snow? Why you got to be like that? The European, yesterday, it was very confident of snow. All these numbers, look at all the pink. Pink is like nearly 10 inches to a foot of snow. I mean, it was so super confident. Today, a lot less pink on this chart, a lot more white spaces, meaning it's having a tough time to figuring out if it's going to stay all snow or not, and it lowered totals as a result. If you do look kind of a flat plane of the European and other model data, it's just to show you where the clusters of snow is for each individual run, because they get nudged in different directions with different variables. Look how variable this is. And you want me to give you an exact snowfall amount when I've got this to work with? There's an old saying, garbage in, garbage out. So you can't expect a whole lot when I've got garbage coming in and I've got to do perfection coming out. It is not easy. All right, here's the SREF, by the way. This is the one that went nuts with us when I showed you the some of the data last night with it. It seems to have a little bit of a cold bias in these type of situations, so it really dumps the snow. I mean, that's a foot of snow across many areas there of central, southwestern Oklahoma. All right, the Canadian, feast or famine. It's almost like the event didn't even happen for Oklahoma in most cases. And there you go. So when I showed you this last night, there were a lot more members that had a lot more snow. Now there's about half of those with no snow. If you do look at the SREF here at Oklahoma City as a point sounding, it does say 5 inches of snow here. This is the average. It does go up to 15 inches up here and then down to a trace down here. But most of them are grouped here in the 5 inch. And there's another secondary grouping up here in the 10 to actually the foot category. I would love to see it be all a foot of snow. I really would. It'll melt fast, don't worry. I just would love to see that much snow. All right, so here's a look out here, western Oklahoma. A moderate impact indicated by the accumulation of the models in this particular product that's generated as a result. Major impacts in red here across the panhandle. So again, the panhandle of Texas, there's no question it's running out there and getting hammered. They just will. Temperatures, well, 30s for Sunday, 40s and 50s for Saturday, and then we'll warm things up starting Monday, Tuesday on into next week. So that's it. I'm running out of time. I've already gone over my allotted window. I'm going to get in trouble here. So real quick, storm system still coming in Sunday. Starts off with rain, transitions over to snow quickly in far western, southwestern Oklahoma during the mid-morning hours. And then once we get into the mid-afternoon hours here in central Oklahoma, it starts to transition from southwest to northeast. That means Oklahoma City. Anytime after 2 or 3 o'clock is fair game for us to either start mixing it in, going back and forth for a while, or maybe it goes all snow and stays that way. It's going to be around that line for a few hours. By the time we get to around, I think it's 6 o'clock, I think at that point, the model data had us transitioning over completely from that point forward. So any snow we do get will accumulate in that window as well. And then that kind of whole system moves northeast from there. That takes the snow width along the I-44 corridor to Tulsa during the evening hours too. If you guys, probably toward the end of the Super Bowl, kind of 8, 9 o'clock, something like that, where you got to transition over. So unfortunately for the kids, it's an evening, late afternoon evening deal. So you might have to let them play outside in the dark. It could be worse. Like I said, the ground temperatures are warm. As you saw, the air temperature is still pretty warm. So the melting is going to come in on both sides. So even if it's snowing to beat the band, it's going to be hard to measure what actually fell from the skies. So if a foot of snow falls, for example, and you can only measure 4 inches when it's all said and done, it's not that it snowed 4 inches. It just melted so fast. It's all you could get at the particular time. So that'll be the most difficult part of this, other than the fact of the exact little areas that I outlined of that little track of the spots of snow that occur where it transitions over. And everybody else has got a cold rain, is upset about it. Can't please everybody. All right, so that's it. That's what I got here for you. That's all I can give you. I'd give you more if I had. I would give you a better solution if I could, and that's what I have to work with. So that's what I got to tell you. We'll look at the data again tonight, and the good news is it has not looked like it's going to be all rain. So it still looks like there's hope on the table for the transition over to snow. I'm still leaning on heavy with the NAM for the thermodynamics and the temperature profile. So if for whatever reason that was out to lunch today, and it's just a degree warmer, all bets are off. So tonight I'll see what I can do for you, and and then Saturday, unless there's more agreement, if there's less agreement tonight or it's still 50-50, that means I got to push it to Saturday, which is lame. But I've given you what the forecast I've got here already. That's same as I've had for the last few days. I'm not going to change it until I have a hard concrete reason to, and I don't at this point. So we'll just go with the mixture of rain and snow with accumulating in spots and then melting quickly. But that's it. So you guys have a great weekend. If you don't watch anymore, if you don't hear from me, you've got the big picture. Enjoy your weekend. Enjoy your Super Bowl activities. Be safe out there and on the roadways. I'm sure at some point they're going to be a little dicey, but then, crews will be out there and then things will melt pretty quickly. And Monday, temperatures will be cold in the morning, probably below freezing. So any water on the roadways, bridges, overpasses, that kind of deal may become a little slippery. So be careful out there on the Monday morning. I do not know if schools will cancel. Don't ask me. I'm not the guy that makes that decision, but you'll know it. I'm sure they'll tell you. All right, guys, be good. Have a good rest of your day, and we'll see you later.